Okay, so what we're going to be looking at today, a number of different bits and pieces here. So we're going to start off looking at VIRL itself and give people a bit of an overview. This may be a bit of revision for people, particularly if you're already VIRL customers. We're then going to move on and look at how you can build custom virtual machines. My colleague Brian's going to take us through a section on network connectivity, focused really on how you can connect VIRL to other systems, be those physical, be those virtual, with the ability to extend and enhance the environment that you're building. Then my colleague Tom's going to cover some of the less well-known capabilities but very powerful capabilities that we have within VM Maestro. We've got a guest speaker a little bit later, Anthony Burke, who's a fairly prolific blogger. Some of you may have come across him at his blogger site in Network Inferno. And then towards the end, we're going to give you a sneak peek of some new features, new functionality that are going to be coming out in the very, very near future for VIRL, and obviously Q&A. Keep the questions coming throughout the session, and obviously we will try our best to answer those, and maybe we'll pick up a few of the questions towards the end. Okay, so to the beginning, let's get going. So VIRL Personal Edition. We don't know, obviously, how many people already have VIRL, how many people are thinking about VIRL and want to understand more. So this is a little bit of revision. You know, what is VIRL? What were we trying to do when we were building this? So even within Cisco, as difficult as it might sound, or difficult to believe as it might sound, that there's never enough network equipment around, even for all the various engineers and support guys that we have. There's just not enough of this stuff. Everybody wants to have their own environment. So this is really where virtualization comes into its own, because if we can have an environment with sets of virtual machines that provide us with the capabilities that we need to be able to build complex network models, even simple network models, that's a huge benefit in getting up away from physical hardware and being tied into all of that. So with that environment, just because we have virtual machines, that's not we're not done at that point. We want to have an environment where it's very simple and easy to design that network. So I can literally, drag and drop to create that environment that I want. But then, as I'm sure you will have noticed, when you're working with a small set of virtual machines or small set of network switches and routers, 3 machines, not a problem. 4 machines, yeah, okay. But as we start to get to like 10 machines, 15 machines, doing the configuration piece is difficult. There's a lot of overhead in setting it all up, and of course we all know it's very easy to make mistakes. It's very simple to fat finger something, and the next thing we know, we've got a mismatched subnet mask, and things aren't working right, and we're spending our time questioning, what did we do, how did we get here, what's happened. So that's where the configuration engine, this thing called AutoNetKit, really comes into its own, giving you the ability to just push a button and have all the configurations built for you. Another key piece is, unlike various other systems that have existed in the past, which are simulations, so partial simulations of pieces of the operating system, the virtual machines that we're running here, and we'll look at these in a little more detail in a moment, are running with the same operating system code. They are drawn from the same operating system code as the code that you would run on the physical equipment. So that's a key thing in terms of features and functionality that are coming in. And the other key capability is, with the systems themselves, once we've designed an environment, configured it, we're able to save the entire configuration, so the entire description of the virtual machines, their configuration, the network connectivity between them in a single file, which means that I can take that file, I can hand it to a colleague, they can then use that file, and they would be able to bring up an exact copy of that environment that I've created. So portability and repeatability, very, very key. And as we mentioned, the ability to connect to physical devices, other networks, we're going to cover that a little bit later on in this session. So the virtual machines, what do we have? Today, we provide a series of virtual machine operating systems, XR, NXOS, iOS XE, iOS itself, all in virtualized form. So what we have here are virtual machines where we have exactly the same control plane code, exactly the same management plane code, but as we've noted on the slide here, these machines do not have representations of ASICs. And as you'll know, certainly with the bigger end devices these days, all the forwarding operations are performed in ASICs. So what we've had to do is implement a software-based forwarding plane. What does that mean? Well, particularly with certain kinds of forwarding plane-based features which are reliant on ASICs, because we don't have those ASICs, the features may, in some instances, not work, or in other instances, the performance is very, very slow. So, of course, these are not designed to be replacements for physical hardware. These are just simulations that are running the same operating system as we've seen on the physical hardware. So, same management plane, same control plane, same undocumented features or bugs in some cases, but that's what these things are designed to do, to give us that capability to sit down in front of one of these things as if I was sitting in front of a physical device. And we can handle third-party virtual machines. So we'll talk a little bit about what the underlying hypervisor structure is, but certainly we include straight off the Ubuntu Linux distribution, but certainly you can plug in your own. So if you're a Red Hat fan, absolutely you can plug Red Hat instances into that environment. Cirrus machines, perfectly feasible to do all of that. So how is this actually operating? Well, we're using this thing called nested virtualization, running virtual machines on top of a virtual machine. So the vast majority of our customers today are installing the VIRL software stack on top of a hypervisor like VMware, so ESXi, Fusion, Workstation Player. A smaller percentage are doing something called bare metal. We'll talk a little bit about that. But the key capability is this thing of being able to run virtual machines on top of a virtual machine. So we deliver the VIRL virtual machine. That's this layer here, the Ubuntu piece. It's got KVM, and then inside it we're then running our sets of virtual machines. And a foundation of all of that, one of the key capabilities that we rely on is this thing called Openstack. So bear in mind that when you have VIRL deployed, you have a viable live instance of Openstack. So if you're interested in understanding more about Openstack, here it is. You have an environment that you can use to learn, to experiment, and understand how the system is actually working. So key services within Openstack are shown here, but certainly for us, the major blocks are Nova, which is handling all the virtual machine control levels. When we request a virtual machine to be spun up, it's Nova that's doing all of that work. We have Neutron that's stringing our virtual machines together and providing network connectivity between the virtual machines. And down at the bottom, Glance, that's the image database, where the virtual machine images that we mentioned a moment ago, those are all stored. And on top of that, and you can see that over actually to the left in this diagram, is the API interface. So OpenStack is a work in progress. We're currently using OpenStack Icehouse. There's Juno in progress and Kilo that's coming. So there are changes that are happening to the interfaces, and we want to try and give a relatively standardized environment. And that's where the API interface that we provide, the VIRL middleware layer, this thing called Service Topology Director, comes in. So right at the top, the piece that everybody will be using is VM Maestro. This is our user interface through which we can design our environment. So literally drag and drop, and Tom's going to cover this in more detail a little bit later. Drag and drop, set up our basic configuration elements in terms of our design, and then we push a button and hand it over to the automated configuration engine. But this is the environment through which we then connect into our sets of machines. So once we've designed an environment, what are we actually building? It's an XML file. We create these things called .virl files, but if you look inside one of these things, it's an XML file that contains information about the sets of nodes and links, and then also the configurations that we're building for each of the virtual machines. So it's a single file, very simple to then hand over to colleagues. They can then make modifications, hand it back to you, and within VM Maestro, there's also the direct ability to link in with Git repositories. So you can have multiple users all hooked into the same Git topology, able to then see and share files as we're using them. So AutoNetKit, that's the configuration engine. That's where we're taking our design. So for example, 4 nodes in that triangle configuration, setting attributes to say, well, what is my IGP that I want? I want BGP. That's a route reflector. These are route reflector clients. Push the button, and it then processes that configuration for us and produces 2 things for us. The per node configurations with the correct syntax for the operating system that we've selected. So obviously there are differences between iOS XR and XOS, iOS XE. AutoNetKit understands all those nuances and builds the correct configurations for us. And in addition, we get this set of topology renders. So a series of diagrams that show us in detail, visually, what is going on inside our network environment. Which devices are communicating with which devices. So for example, here we can see OSPF areas highlighted over on the left, BGP communication sessions in the middle, so we can see our route reflectors, our route reflector clients, and our peers. So what we're trying to do is to take relatively complex sets of configurations and break it down by building diagrams that we can see. We look at diagrams, we look at maps, we look at pictures, we understand data visually, and rather than sort of sitting there looking through hundreds of lines of configuration to try and figure out what's going on. Oops, skipped a slide. So a key piece, a glue layer that we have that's sitting in the middle is this thing called Services Topology Director. That is the translation layer that's taking our diagram and converting that into a series of Openstack calls, requesting the spin-up of the virtual machines, requesting the creation of the various networks. So that's that key glue layer and the API that says sitting in the middle. So when we look at the system end-to-end, we're starting off designing our environment, building our configuration up and saying, okay, this is the topology that we want, setting our various parameters. We may push the button. We don't have to, but we can push the button to build our configurations. And we get our topology diagrams as we mentioned. If we're happy with that and we're ready to launch, we're then passing that off to the Service Topology Director. It's then translating that diagram into a series of OpenStack calls. We then get the sets of virtual machines coming up together with that configuration that we passed in. That's all loaded directly at runtime. And what we end up with is a series of console accesses, SSH accesses, all the coordinates that we need in order to then communicate with that set of virtual machines. So how do we deliver it? Two different versions of delivery. We have the OVA delivery and an ISO delivery. So the vast majority of people are taking an OVA, which will then load either on ESXi, Fusion, Workstation, or Player, depending on which of the various hypervisor choices you choose. So on top of that, that OVA is then containing Ubuntu Linux, OpenStack, KVM as our hypervisor, VIRL Service Topology Director, AutoNetKit, all of the rest of the elements that we just described. So that is delivered as a single package that then runs on top of your system. If we look at a bare metal installation, it's the same building blocks, this time delivered as an ISO. So now instead of having the VMware hypervisor layer sitting in between at the bottom, we're directly installing on top of hardware. So you end up with the same stack, the Ubuntu Linux, OpenStack, VIRL middleware layers, etc., but directly running on top of bare metal. Okay, so what products do we have that are out there using VIRL? Well, obviously VIRL Personal Edition is now out there. It started shipping at the beginning of December. Really aimed at individual users, coders, developers. We have consultants who are using it as their own personal lab. But key piece, community support only, no TAC support, and you are limited to a maximum of 15 Cisco nodes. Okay, so a key point, 15 Cisco nodes. You can run as many third-party virtual machines as you like, subject to the amount of memory, CPU that you can throw at the virtual machine itself, but you're limited to a maximum of 15 Cisco nodes at any point in time. Cisco Modeling Labs, so that started shipping back in August last year. Same underlying foundational technologies. Again, it's using VIRL underneath, but this is this product is aimed at corporate users. So price point is very different. Key capability is you can pick up the phone and yell and scream at the Cisco TAC engineers, so TAC support is included, but it works on a different mechanism in terms of a sliding scale depending on the number of virtual machines that you want. So the more virtual machines, the higher the price point, but that's really aimed towards corporate users. We also have VIRL included in other products, and you'll see more of these in the future. So we have a product, this thing called DevInnovate, which is really a developer-centric cloud development platform with a whole series of new burgeoning technologies that can be included in there. Underneath the hood, you have VIRL providing that infrastructure layer. Okay, so moving swiftly on. Custom virtual machines. We're going to talk a bit about how you can build your own virtual machines and add in your own software into those environments. Okay, so with VIRL, we include an Ubuntu 14.4 cloud image. What is a cloud image? These are stripped down, lighter weight So they're not the full server and certainly not the full desktop distributions. You will find cloud images for distributions like Fedora, like Red Hat, and others. Okay, so they are designed for deployment in platforms like Amazon. So they are smaller, they are lightweight, but that also means that key capabilities, things that we're typically used to, even things like traceroute, are missing, which can be very, very frustrating. So we can take one of these images, use it as a base, and then add additional packages that we might want to use in on top. And that's what we're going to show you how you can do that. So for users who've got VMware Fusion Workstation or Player, running on your laptop, which is typically the vast majority of our customers, you can actually provide direct internet access using NATing capabilities into the virtual machines that are running inside a VIRL environment. So there are a couple of settings which we describe here in the slide that you need to enable, but once you've got that enabled, you're then able to make a little tweak to the VIRL configuration to say for the flat network, and we'll show you how this works in a moment, use a gateway at a very specific IP address. Okay, so VMware uses a NAT device that sits at that address, or 172.16.1.2. Okay, so normally our gateway will be set up to 1.1, but if you change it to 1.2 and then you run through the steps, the vinstall rehost, the vinstall renumber, what happens is when those virtual machines are spun up and you connect them to a shared flat network, so here what we're doing is we're taking our out-of-band management network and saying we are using shared flat network, so each one of these devices that you see in the diagram will then come up on that network. They will then receive a default route from 172.16.1.2. That service then provides us with a NAT capability. So when these virtual machines come up, they are able to reach to the outside world. They're NATing using your internet access, and they're able to then talk out to the rest of the internet. So in this diagram here, I've got a virtual machine that's spun up, our Linux server. It's got a default gateway. You can see that highlighted, so 172.16.1.2. And then I'm able to run my normal commands. So things like DNS is working, apt-get. Oh, so in case of Red Hat users, you'll be using something like RPM, or you've got wget, your normal web browser capability. You can then pull down your additional packages and install those on top of your virtual machine image that you're running right there. So I can do various things. I can automate something like this. I can then say, okay, I know that I'm always coming up with internet access. Therefore, I'm going to modify my configuration, and we can see that in the example here, to always reach out on boot up, grab my package. So in this case, I'm installing Apache, and install it. So I'm turning off the auto-config function. I'm putting in my own line of configuration. So I've used AutoNetKit to build my basic configuration, and then I'm modifying it. I'm extending it. I'm saying, please add this particular package. So each time that virtual machine boots up with this configuration, it's going to reach out, grab Ubuntu, and install it. Well, that might not be what I want to do. I might want to just set the system up and have that snapshotted. So I want to effectively build my image up, save those changes, and then make that reusable. So we can do this using something called snapshotting. So I'm going to bring up my virtual machine. I'm going to add my various packages. And once I'm happy that I've got the packages I want in place, I need to create a snapshot, a clone of the disk. And the way that we do that is we log in as the user that we're running our simulation under. So in this case, I'm logged in as user guest into the user workspace management interface. I then see under sessions a series of menu options, one of which includes my simulation. If I click into that simulation list, I can then see my list of nodes, so iOS 123 and the servers 123, and over here on the right-hand side we then have this option, Create Snapshot. So if I press that button, what it's doing is it's cloning the active disk from that virtual machine, and then I can reuse that. How do I do that? I then will have that cloned image available for me to select. So if I then stop my simulation, go into the design mode, I can then select from the VM image. If I press Browse, I will then see a new image. So I can see my server, my original NXOS, etc., and now a new image And this is my snapshot that already has, in this case, my Apache server installed. I can also export that image. So I can take that virtual machine image and take it outside from my VIRL platform. So I could hand it to a colleague and say, here it is. Here's the system that's already got whatever tools I've packed into it. So using these commands that we've listed here, and the example is just an example, I'm then able to download and take that virtual machine disk image and then take that over to another system where it can then be installed and used. Okay, so that's a very, very fast run through about how we can create custom machines. I'm now going to hand over to my colleague Brian, who's going to take us through a lot of information and a lot of detail around how we can then connect VIRL up to other systems. So Brian, over to you.
Okay, thank you, Joel. As Joel said, I'm Brian, and I'll give you a quick overview of how you can connect VIRL to the outside world. Ahead. So as useful as VIRL is just by itself, it's even more useful when you can connect it to existing infrastructure that you may have inside of your home or your corporation. But this does require some planning. We need, in some cases, to match the IP address spaces being used inside VIRL with those on the outside of VIRL. So before we get there, let's talk about some terminology. So the VIRL host is the machine, the physical machine, or the virtual machine on which VIRL is running. The VIRL node, excuse me, is an instance that is running inside of VIRL. That could be a router or a switch or an appliance that Joel just described. A topology is the collection of those nodes, and a VIRL network is a IP network that's used inside of VIRL to either connect those virtual machines or to connect those virtual machines with the outside world. So VIRL has a number of network interface cards, and those, of course, are connected to a number of different IP networks. So let's review those quickly. So the first, generally ETH0 on the VIRL host or virtual machine, is for management. This one's mandatory, and it's the mechanism that you use to connect to the VIRL virtual machine and therefore the nodes inside of it from the outside world or from any management network that you use to connect to that host. The second network interface is connected to FLAT. The second and third actually are both connected to FLAT and FLAT1. These networks are used for layer 2 external connectivity. So what I mean by this is that the address space that is used by the VIRL simulation is extended beyond the host to the external site networks. These are typically on 172.16.1 and .2, although these can be adapted at the time of VIRL installation to match the address spaces that you're already using. The fourth interface, which should say ETH3 here, but it says ETH2, it's ETH3. The fourth interface is connected to 172.16.3, but this is statically translated to a different subnet outside of between inside VIRL and outside VIRL. This is useful in certain circumstances where the address spaces don't overlap completely, or you just want to have a different address space inside versus outside. And then the fifth interface is for cluster control or inter-networking. This is going to be used for a future capability where you can perhaps use multiple compute nodes in a VIRL installation. Now those are all subnets that span from inside to outside of VIRL, but there are a number of networks inside as well. So for a given simulation, you can have a management network, and then, of course, the data plane links that go between the VIRL nodes, and we're going to talk a little bit more about those later. But before we get there, it's important to understand the distinction between projects and users. So projects are similar to Openstack tenants, and these are collections of users, and it's important to understand the concept of projects because that's the device or the element in Openstack to which resources are assigned. So within projects, you have users. Typically, when you create a project, a user of the same name is also created, but it's not always that case. So in the illustration on the right, we show a project guest with a user guest. But we can also have a project called ops where they have different users, Jim and Bill. Now, the reason this is important is because there's a networking concept or a management interface concept in VIRL that is related to projects. So let's look at that in a little more detail. So one of the things that you want to do when you have a VIRL simulation, or you may want to do, is connect the management interfaces of the simulated nodes to something that you can get access to. So when you choose a private management network in your simulation, you can see that the management interface of the two routers that I've spun up in my simulation are connected to a network, but that network is isolated. It's not reachable from outside, and the routers can see each other, but they can't see beyond the VIRL host. If I choose a private project management network, it remains the same. I still can't get beyond the host, but multiple simulations within that project can see each other. So, for example, going back to the previous slide, a simulation that's in the project ops, Jim and Bill would be able to see each other's management interfaces within their simulations because they exist within a given project. Then there's this concept of the shared flat network. In this case, the management interfaces are connected to this flat construct, but that flat construct allows the connection to devices outside of the VIRL host. So in this case, you would be able to access the management interfaces of the routers or the other images running in my simulation from outside, be it via or from a network management functionality, some sort of SDN controller, or maybe a network application that I'm building. There's also flat data plane connectivity. Now, it's important to note that you can't use data plane connectivity, flat data plane connectivity, and flat management plane connectivity at the same time. In this case, I would have to use a private or a private project management network, but the data plane interfaces for some of my routers could be connected to flat and therefore have their connections extended out beyond the host to something in the real world. And it's important to note here that we can use things like 802.1q VLANs, and they can be extended beyond the host to a switch and perhaps broken out to go in different directions, east and west, or to go to different user spaces. Now, this concept can also be used with SNAT, the SNAT interface, but the main difference with SNAT is that there's a translation functionality, which I've attempted to show in the diagram as a NAT functionality. So note here that the address space being used on the data plane connections is different than what would be exposed externally. So, and this would be translated in a static fashion so that, for example, 10.255.10.1 would always be 172.16.3.1 on the outside. So by using these various techniques, we can address a number of VIRL use cases. So, for example, on the left here, I'm showing that you've got some sort of an external network management element or an SDN controller or some sort of an application that you're developing to test network APIs being attached to VIRL so that you have a network against which to do your testing and development. Very important use case there. In the middle, we may have a VIRL simulation that we want to connect to one or more real external networks so that we can get a larger simulation space or see how my VIRL simulation is going to behave when it sees a large number of external routers and other network devices. So that's VIRL surrounded east and west by real networks. And the third use case is perhaps where you have a system that you want to test. Say you want to test the new features on a new hardware platform and so on. You don't have the funds to purchase a large number of these, but what you can do is take that device under test and surround it with one or more VIRL simulations so that from its perspective, it's connected in the midst of a very large network. So that's the quick rundown of VIRL connectivity. At this time, we're going to hand over to Tom, who's going to give us an update on VM Maestro.
Thanks, Brian. Okay, so today we're going to just cover a couple features for VM Maestro users. These are in the existing product. They're so you already have them available, and we're going to do local history and some topology editor preferences that are perhaps not obvious but useful in some specific use cases. So we had some problem with lag earlier on the previous call, so I'm going to actually try to do this demo live. We'll hope that goes well. Okay, so everybody should be seeing VM Maestro here. So the default with VM Maestro, when you're adding nodes, for example, is that as soon as you click, you'll see the cursor here has a sort of plus icon next to it. So you can continue adding nodes of the same type. That makes it quick to add new nodes. That does mean that if you want to select one of these nodes, set properties, rearrange their position, you either need to go to the palette to click the select tool, where you can then move the node around or set its properties. Or if you're in this mode where you're adding nodes, you can also just press your escape key, and that'll get you back to the select tool. And then similar thing with connections. When you're creating connections, as soon as you finish one connection, you can then click and create the other one that stays in the connection tool. I'm also going to show here in the node editor. You'll see that as we're adding connections over here in the node editor, for example, iOS v4 has two Ethernet interfaces. When I create a new connection, iOS v4 gets a new DE03 interface. So every time I add a connection, interfaces get auto-created, which is fine. It makes it very fast to create your topology, but that also means that if I have this connection here between iOS v3 and iOS v4, and I want it to use DE01 on both sides, I see that it's not, and I could try to come over here and reconnect to the DE01, but VM Maestro is not going to let you do that because iOS v3 already uses that DE01 interface in one of its other connections. So rather than try to go through here and disconnect things and rearrange those connections, we'll show you a quicker way to do that here. So we're going to restart this whole topology after settings and preferences. So under File, Preferences, there's the Topology Editor Preferences. So there are two settings here that I want to talk about. The first is revert back to the palette's default tool. By default, this is not selected. If you select this setting, click OK. When you then add nodes, you're immediately back to the select tool. So normally, as we saw before, you can just drop multiple nodes here. As soon as I drop a node, it goes back to the select tool. That can be useful if you prefer to set your settings as you go. So as soon as you drop the node, you can click select it and go down to set its properties. Or if you want to, if you're creating a topology with multiple different types of nodes, you're going to be going back to the palette multiple times anyway. That can be a useful setting. That setting also affects the connect tool. So every time you finish creating connection, you're back to the select tool. So you have to keep going back to the connect palette there. Personally, I don't find that super useful for connections, but some people like to use it. We're going to go back to preferences and shut that setting off. The other setting is the associate new connections with interfaces silently. So I'm going to disable this one. By default, it's enabled. So if I start this one again, so we're going to create this whole second. Oh, awesome. I don't know what state I got the user interface into, but here I'm going to create this one again. Perfect. Okay. So going back, the important thing here was the setting for the don't auto-associate the connection, the interfaces with new connections. So with this, with that setting disabled, when I go to create a connection, I'll get a list of all the possible interfaces on this node. So like I said, I want iOS v3, the connection between it and iOS v4 to use gig E01. So I'm going to skip that interface when I'm creating this connection and use gig E02. So you see the node here, iOS v3, in the node editor. You can see that it has a connection just going to gig E01. It doesn't yet have a gig E02. It does not yet have a gig E01 interface. So I can do that when I'm creating connections. Basically, I have to select every time, which is fine. When I come here to create the connection between iOS v3 and 4, I can select the interface gig E01, so that now gets added to iOS v3. So this is a useful setting. If you're creating specific topologies, you know exactly which interfaces you want every connection to be on. This is a useful setting so that you don't have to create the connections in a specific order to line up with the way VIA Maestro auto connects them. So again, both these preferences are set for you under File Preferences, Topology Editor. The default is for this revert back to the selection tool to be disabled, and for VIA Maestro to automatically create interfaces as you're creating connections. But again, this is useful to disable if you have specific topologies that you want with connections going to specific interfaces. Okay, the other feature that Joel asked me to talk about today is local history, and so this one is let's see. So right, this is a topology. If you've seen the recent videos posted on IGV configuration and BGP configuration in VIRL, this is the topology that you end up with at the end of that second video. So if in general in VIA Maestro, if I add something I don't want, I can just do edit, undo, and get back to where I was. That's fine. But if I close the topology, or if I've done multiple changes, like I've created this whole topology you see here, lots of different changes going on. If I want to get back to an earlier state, it can be difficult to do just through the undo feature, or if I close the file, I've lost my undo stack. So local history, you can access through the team show local history. It's just this history view that usually sits here behind the project view. But once that's open, you'll see it's referencing router protocols. And this is showing you sort of, VIA Maestro is saving basically every time you save the file, it keeps a copy of that file in its own local history storage. And there's some settings here to tweak how much space it'll use for that, but you'll get as you see quite a few changes here. So just like you do if you did the AutoNetKit router configuration auto generation, you can see the diffs there. You can see a similar thing here where you can right-click on any of these previous versions and do a compare with local. So this is comparing that specific version of history to the local file. You can see here on the left is the local, and the history version from earlier today on the right. And then I can use the steppers to step to the next change, or I can do sort of stepping through by chunks the whole sort of regions of change, or if I have a region that has a lot of individual changes, I can step individually through those. The other thing that I can do here, if I want, I can compare two versions with each other. If I just want to see what a previous change made, those two are actually identical. But if I go back a little farther, we get a couple that'll have changes between each other. The other thing that you can do here, for example, if I'm looking at a much older version of this file, I can try to open that with. So it'd be nice to open this directly with the topology editor. We don't quite have that working, so this is not supported yet, even though it's there as a menu option. But if you want to see the previous version, you can open it in a text editor, and from here I can say File, Save As, and then save that, just as a temporary file. Notice that it comes up by default here with a space at the end, so make sure you remove that space and just save it with .virl. So now this is the file that we just saved. So this is an earlier version of the file that I had from earlier today. And I've pulled this out of the local history. So that's the version that you get at the end of the IGP before you do all the BGP configuration with the hierarchical route reflectors. So if I go back to my history and I like that version that I just grabbed, that was the one from 1030, I can actually say, okay, from here on my routing protocols file, grab the file from 1030, and actually, I don't want this one anymore. I prefer that, this is a nice experiment, but I decided this is a bad idea. When I go back to this earlier version, I can say get contents, I'll get a confirmation, and the file will just be replaced completely with that older version of the file. So now essentially the version from 1030 is my new version at the top. You can see if I select both of those and compare, we get identical files. There are no changes. By default, the history view does track with whatever file you've selected. So if I select simple, I get the history for simple. If I select routing protocols, I get routing protocols. If you want to disable that for some reason, you can disable this left and right arrow button. So now when I switch files, it'll just stay on whatever file I last synced it to. And I can always open it on some different file by saying team show local history. Now it switches to simple. It stays there until I either show local history again from someone else or re-enable this link. So I'm back to whatever my active file is. So that's local history. It lets you do the diff for the the same way that you do with AutoNetKit generation between any couple versions from your history. And then also it helps you recover if you for example close a file and accidentally save it with some changes you didn't want, or if you closed a file before you had a chance to do undos. So those are the two features we wanted to cover today: the local history and some of the topology editor preferences. Now I think we throw it over to who's next here? Oh, our guest speaker.
Okay, while I get this set up so at Pandem is Anthony Burke. And Joel, I didn't know if you wanted to do a quick intro.
Sure, absolutely.
Go ahead, and then I'll set up the audio.
All right. Okay. So Anthony Burke, who goes under the handle at Pandom. You can also find his blog at networkinferno.net. Anthony has actually been really helpful, was involved in some of the beta program that we were running, and very kindly put together a recording. Unfortunately, he couldn't join us today, but he's going to give us a very brief, it's like 5 minutes or so, about some of the things that he's been doing. But do please take a look at his blog posting. There's a lot of good information on there. And Jocelyn, over to you.
Okay, great. Here we go. We're going to queue up his audio recording.
Hi, my name's Anthony Burke. I'm in the Network Security Business Unit at VMware as a Systems Engineer. I've been networking now for about 5 years. I started off as a entry-level desktop network guy, and then I moved into integration role and went and started to work for emergency services and ended up VMware started last year. I've been using VIRL now for about 6 months, and in the beta it showed real promise. We saw all the videos, we saw all what it could do, and it was really exciting to provide feedback in the early stages and help deliver what the product is when it's GA'd. So since it's GA'd, I've been doing many things on that platform, and it's been quite an exciting time. So my primary background is routing switch, NSX, given that I work for VMware, but I have a real passion around OpenStack and operations and management. So I'm a firm believer that a product is only as good as week one operations and how you use and consume it, but also how you keep operating that environment. You may know me from networkinferno.net, my blog, and I'm on Twitter as @pandem_. So I was asked to come on today and speak about my VIRL use cases. For me, my primary use case is a personal use case, and that's for using VIRL for CCIE study. So I'm currently going for my CCIE route switch. At the time of this webinar, I'm about to sit my written exam for V5, and what's been an integral part of my study has been VIRL. And I say that because traditionally a lot of reading, I use GNS, as many of you guys have out there, and it provided much functionality, but what was concerning was when you're learning a new topic for the first time, knowing that is it GNS that's breaking, or is it the lab that's broken? Are you understanding OSPF, or is it a bug in the fact your CPU is too high? And these were all considerations that ran in the back of your head, and when you're looking to become intimate with a routing protocol and understand it at the protocol level, you need to ensure that the platform you're working on isn't buggy, and that's where VIRL has been fantastic. I know that I have a rock-solid platform that I can get on with, focus on labbing and doing things as opposed to troubleshooting my environment. I would say that, and I've said this before to many people, that I have studied more with hands-on lab time using VIRL than I have with any other platform. I've been able to spin up labs quickly. AutoNetKit allows me to quickly plot out numerous routers and devices, have them automatically configured, base level routing protocols done, IP addressing done, and I can get on with studying. And I think that's the most important part is I've got a 6-month-old son. I have limited study time and I want to focus on spending time with him. But when I do have time, I don't want to be troubleshooting my lab. I don't want to be IPing my environment. I want to just lab and learn things. So that was pretty cool there. I went on and made a INE, it's Network Expert, CCIE lab topology, which has been quite popular on the blog, and that's what I've been using for most of my studies. We all know there is a limit of how many routers you can use, and that is in place, but you know what, I focus on doing practical things. So if I can't use 25 routers in my environment, I'll use 15, I'll use 10, but I'll work on understanding the protocol in the relevant topology, and that's pretty cool stuff. What I've also been doing lately, which has seen a bit of traction, is integrating third-party platforms into VIRL itself. Due to the Openstack architecture of VIRL, it's quite easy to slipstream and integrate other operating systems and other networking toolsets into this environment. And so hopping into the user world management portal, adding in the ISO as required, or the MDK, and off you go. You put it in, the parameters are passed through Openstack, and you can deploy it and use it quite easily. You know, that's been pretty good for multi-vendor topologies. Like, there's numerous environments out there, and I had one in production where I had Juniper SRX as my DMZ firewall, and I had ASA 5585Xs as my DC firewall. And having the ability to spin up and test and validate interoperability is awesome stuff, because beforehand you were required to get two of those kits, two boxes to sit together. You could assume that that would work on a per box basis, but my previous life had 80 odd ASAs and a half dozen SRXs, and I can't reproduce that in the lab. But with VIRL, I can, and that's a pretty exciting prospect. And I suppose the last one that I'm doing, which might be a bit different from most people, is that I'm using VIRL to simulate data center networks where I plug in NSX at each end. So I'm able to simulate multi-data center topologies. I can simulate WAN environments, simulate latency and the rest of it across my environment, and test how overlay technologies work across the top. And this has proven really good for me environment. As opposed to just using a vSwitch and faking multi-data center topologies, I can actually deliver this across the Nexus platform or across a CSR or something like that, which will allow me to show a customer a valid proof of concept, which is pretty cool stuff. Whilst these have been my use cases, which I have now working and whatnot, I've been able to, I'm thinking about the idea of using that management network for service VMs. So the idea you could have monitoring topologies or capturing net flow, and so my ideas in my head are rambling around. They're pretty exciting, and this platform has a lot of potential. And I think what I implore listeners to do is to go out and think, what can I do on this platform other than just study? There is more applications than just study. There's a lot of real-world things, a lot of good test-bed environments for you to try new things, to try new architectures, to try validate something that worked, quickly spin up an environment to enable you to see if a feature set does what it does on the box, but also will it work in your production environment, or does it solve a problem? And I think whilst routing and switching are very core concepts and quite easy to reproduce, it's firewalls and the integration into it. How does a route change across, the state replicate across two firewalls? Have I got it set up correctly? And I think that's where the real value is to, as part of your, as my old man says, measure twice, cut once, is that you can validate and do due diligence on this platform and actually say with more confidence than ever, yes, this change will work. And and that's pretty exciting stuff. So thanks for the time and allowing me to share what I've been doing on VIRL. If you have any questions at all, feel free to reach out, and I'm happy to answer them. Thank you.
Okay, great. So Joel, I'll hand it back to you. This is probably the part that everybody's been waiting for.
All right, thank you. I'm going to grab the ball. Oh, Jocelyn, can you pass the ball? Oh, thank you. All right. So, quick check. Can people see a diagram?
Yes.
Excellent. Great. Thank you. So, yes, new stuff. New stuff coming, a lot of new stuff in the pipe, and want to show you some of the bits and pieces which are imminent, literally imminent. So, first of all, we're looking at the Maestro user interface for those people who are not familiar with it, obviously the UI that Tom described earlier. And we've done a lot of work in updating and revamping the look and feel around AutoNetKit. So just going to show you some of that functionality. So we've got an environment that's here, a number of iOS instances, and set up with the BGP topology. So when we press our build configurations, as we mentioned before, we are then getting the sets of configurations and also the visualization. So new style visualization with a number of new capabilities that are in here. So look and feel has changed. We still have the same kinds of capabilities. So if we want to take a look at things like OSPF, we can see that. Want to take a look at BGP, we can see that. And again, sort of looking at various elements within the diagram, highlights pieces of information. We can point at links and understand what is going on. So that's all stuff that we had before, but we've updated from an old version of the Next UI visualization engine to the new one. Okay, that's not the real piece that we want to look at. Okay, so these diagrams that we're building here are all before we've actually launched the simulation. It's all back in the design phase. But we now have the ability to build these build these visualizations from a live simulation. So in the best traditions of live TV, here is a simulation I've started earlier, and it's this set of systems. We now have a new function that's coming. So when I right mouse click, we now have this launch live visualization. So we're going to do that. And what's happening here is the system is now reaching into the simulation that's running and building a view of what is going on inside my simulation from the system itself. So not from the configurations that we've generated before we launched, but actually from the system as it is right now. So I can switch it into a view. So for example, I'm going to say, give me the OSPF view. And right now, we're empty. And then I'm going to say, grab the information. So what's happening now is it's reaching into those virtual machines, processing that information and rendering it. So you just saw the diagram being built dynamically, not from the configuration that we've generated, but the configurations actually running on the systems themselves. So for example, if I log into one of these devices, let's take iOS v1 and shut down the OSPF process for a moment. So we're going to do that now. There we go. So conf t, router OSPF1, shut down. Okay, so we turned off the process. We can see there go the messages to say everything's being shut down. If I now rerun that collect function, we can see that the sessions are now dropping away in the middle. So if I keep on collecting, re-rendering, and eventually all the sessions are going to drop out as the keep alive expire. So we can see the dead timers on these various sessions. We'll just collect again. And eventually these sessions will then all drop out as the dead timers tick away. Similarly, if we go and grab the BGP and say, right, collect the BGP information. Okay, so again, it's reaching in and we're building up that view so we can see the relationships. And the key thing about this is it means that as you are experimenting, as you are making changes within the system, I can now use this to build a visual representation and understand what is it that I'm doing. So as I make changes to the configuration, it's being reflected directly back in those diagrams. Okay, so we think, a neat form of being able to visualize and troubleshoot what's going on. Also just want to show you something nice that's coming, this 3D visualization. So a bit of a prototype right now, but there is a reason and rationale behind this. So I can now take my diagram, and again, this is grabbed from the live view, and now I can see my different layers. So you can see, physical live, OSPF, BGP, eBGP, and as we look down, we can see the relationship of the various different layers that are taking place at the protocol level. And obviously, zoom in and do all the whizzy bits and pieces that we'd like to do. Go, oh, look, it's 3D. But there is a reason behind this tool, and this is something we're going to be building more on in the future. Okay, next piece. Lots of people have been asking for it, and it is coming. It is coming. We are very close. Let me just switch the server over. Where are we? There we are. iOS L2. It's in the pipe. It is close to being ready for delivery. What we have here, to be clear, is layer 2 switching based on iOS. So not NXOS. Okay, that's still sort of out there to be delivered at some point, maybe. No commitment on that. But what we have is layer 2 switching operating as a iOS-based system. So layer 2 trunking, .1Q, spanning tree, the features and functionality that people have been asking for is coming. So in this diagram, and what you're looking at is an engineering version of VIRL, not the personal edition that you're used to. Got way too many nodes running here. There are 3 iOS V layer 2 instances running in the middle. Logged in on one, or I was logged in on one of these. Hopefully we can bring that up. There we go. Let me just pop that up there. So, and there we are. Let's wake up. Come on. It is being, come on. There we go. Right. Okay. So you've got all the layer 2 features and functionality, so I'm just going to connect in on this other node that we have over here to the side. So this is iOS v1 that's sitting up here in the corner. Oh, yeah, even when you're trying to do demonstrations, you can still make mistakes as you type. So we can see the OSPF neighbors set up, and these neighbors are then spread across the various different switches that we have here. So what we're showing is the ability, as you would do normally, to set up these devices and then have them operating as they would as just regular layer 2 switches. So here we can see, we've got interface trunking in operation. We can see that we're handling trunking for VLANs 2, 20, 30, and we've got these various devices split across. So it's coming. It won't be in the next version of VIRL Personal Edition that we're going to push out. It's not quite there yet, but keep holding on. It's coming. It's going to be available very, very soon. We're almost at the point where we're happy with the stability of the image, and it's going to be ready to go out into your hands. Okay. Jocelyn, back to you.
Great. So I think we just have a few more slides. Oops. There we go. Didn't know if we wanted to, if there were any particular Q&As that we wanted to highlight, but in the meantime, while you guys are deciding on that, just wanted to share some useful links that could be great for some of our audience members if they didn't know about this. In particular, our VIRL YouTube channel, where we have many videos that the engineering team has been posting up. And of course, we have our Twitter account that I wanted to share. So before we close out, because we are 1 minute over the time that we had allotted, any Q&A left? Does anybody want to put them into the Q&A panel?
Sorry, Jocelyn, if you were sharing links, we didn't see them.
Oh, sorry. I forgot.
There we go.
Let me go back.
Thank you.
Thanks, it's late, sorry. So the YouTube channel, and we'll have these slides posted out onto the forum as well, and this particular webinar will also get posted out to our YouTube channel. Okay, great. Okay. Just want to thank everybody for joining us. We know it's Lunar New Year in Asia Pacific, so thanks very much for joining us tonight. or today, rather.